Okay, so now that we have we got our identities down and we've used them to do some exact values, here's something that's relatively new, although I think you guys have been using this kind of idea all along. It's just we're just using it in more detailed and in more algebraic ways. But I'm going to call this, what we're going to do is rewrite or simplify an expression. And what's kind of tough about rewriting simplifications is there's actually, because of the identities, oops, I misspelled simplifications. Anyways, there's really no right or wrong answers. We're just trying to rewrite them. And so that's always kind of tough to do because there's more than one rewrite, as you will see and you will find. But here are just some of the best things you can do under some circumstances. So 1 over tangent. Well, obviously, right, what's a really clear rewrite of 1 over tangent? It's just cotangent. All right, so there again, just using the reciprocal identity, I rewrote the expression 1 over tangent to its cotangent. Of course, the next one's pretty easy too, right? Because cosine over sine, well, that's just our quotient identity for cotangent as well. All right, and you get a feel that we could have also said that since these are both equal to cotangent, right? A rewrite of tangent is also to say that this is cosine of x over sine of x. So there's that idea that there's more than one way to do something. So so whatever just comes natural, these are always hard to grade with regard to this, but this would have been a right answer, and that's a right answer. Of course, you could have said that's that as well. That would have been a right answer too, right, based off of what we're seeing. So just make sure you're clear with what you use and how you got there. Try to be as simple as you can, but that kind of just displays how hard a rewrite can be. So 1 over tangent is cotangent. That's the easiest way. Or if you rewrite tangent in terms of sine and cosine, you eventually get this, right? Or cosine over sine is cotangent, and we're basically working in a wicked circle. And so that's what trig identities are going to feel like. We're going to be working in circles a lot. So which route do we want? Which rewrite do we want? Kind of depends on the problem. Cosine of negative x, well, the easiest rewrite here is just to use our even identity. Because cosine is an even function, it doesn't matter if the input, the argument is negative, right? The output's going to be the same whether it's positive or negative. So that's just a nice, simple, even identity. Cosine squared of x. Here's where it starts to get a little bit harder. What you got to do is kind of search your memory banks. Where have we seen cosine squared? And we can begin by looking at our Pythagorean identity. All right, so at least we have cosine squared. So how do I rewrite that? Well, a simple thing to do is just to basically subtract sine squared theta from both sides. So what's a rewrite for cosine squared? 1 minus sine squared theta. Okay, and to kind of get us ready for the future, right, you could also realize that this is your difference of squares. So this is 1 minus the sine of theta, right, times 1 plus the sine of theta. So there would be two different rewrites. That's the one that seems the most natural to me, just rewriting our trig identity, or excuse me, our Pythagorean identity. But then because it's a subtraction of two squares, I can rewrite that as the difference of squares. So this can go on and on and on in a whole bunch of different directions, okay? So we got that. Secant squared x minus 1. Well, again, we got to kind of think in our memory banks, where have we seen secant squared? And that's another Pythagorean identity, right? We know that tangent squared of x plus 1 is the secant squared of x. So to get secant squared minus 1, how about we just subtract 1 from both sides, and we find that the tangent of x is equal to the secant squared of x minus 1. So one answer is that this is the tangent squared of x, all right, using our Pythagorean identity. Of course, we could have also said that this also is the difference of squares. So this is secant minus 1 and secant of x plus 1. So I would accept both answers if, you know, some of you on the quiz manipulated the Pythagorean identity and said secant squared minus 1 is tangent squared. right? You're just as right as someone seeing this as the difference of squares and rewriting it as secant minus 1 and secant plus 1. They're both considered rewrites. Whether they're simplifications or not is another story, right? That would kind of depend on the situation we're in, but it is definitely a rewrite. So that's kind of, again, where we're going with this. For the next one, again, there's several ways we can do this, but how about I show you this idea? Because we're adding up here, we actually have two fractions. There's the sine of x over the cosine of x plus 1 over cosine of x. And now that I have it rewritten that way, right, sine over cosine is tangent, and 1 over cosine is secant. So a rewrite of this is tangent of x plus secant of x. If we just interpret that as the addition statement that it is and break it up into the two fractions that it is. Is there another rewrite? If we sat and thought about it, yeah, right? We can think of this as maybe as the sine of x plus 1 and then multiplying that to the secant of x, right? Just using the fact that 1 over cosine is secant. So there would be another rewrite where we leave that alone and then just rewrite that cosine in the denominator as secant. So that would be another potential rewrite that you can make. But this is going to get us ready for things we're going to see in the future. All right, so again, for rewrites, all we're doing is taking an expression and rewriting it into something different. There's a lot of different routes we can go, so just make sure you're clear how, if you're using the Pythagorean identity, show me how you're using it. Obviously, if you're just factoring, just show me how you use it, all right, whatever the case might be. So just make sure you're clear with your work, okay? Next, we got to do something that seems a little bit more challenging, but when we think about some identities, it's not too bad. What I want to rewrite is cotangent of x in terms of cosecant. So what we're getting at here, let me kind of go back in the archives. It's like when I want to write a function, right, a in terms of w, what I expect over here is to see something involving w. So that's what it means to be a rewrite in terms of something. So my a is in terms of my w here, and here's how. And so what I mean here is we want to rewrite our cotangent of x, and it's going to be equal to some expression that involves cosecant of x over here on this side. So there's nothing else over there basically. It's just like this expression involves w's only, right? This expression involves cosecants only. So how do we do this? Well, again, it begins with, how do I relate cotangent to cosecant? And one of the best ways to do that is through our Pythagorean identity, right? We know that 1 plus cotangent squared is equal to cosecant squared. And so we definitely now have an equation that relates cotangent to cosecant. But basically, you need to solve for cotangent. So I'll begin by subtracting 1. So that gives us cotangent squared x equals cosecant squared x minus 1. If I now take a square root, we get that the cotangent of x is plus or minus the cosecant squared of x minus 1. The plus and minus would basically play a role in which quadrant am I in, because cotangent is positive and negative in different quadrants. But there is basically your answer. Notice that on this side, I have an expression that has cosecant only. And so we have written cotangent in terms of its cosecant. So we got what we finally wanted. It's basically asking us to get cotangent by itself, and on the other side, just an expression with cosecant. Before I go to the next problem, make sure you're careful here. This doesn't break up, right? This radical doesn't break up. You don't get cosecant of x minus 1 because radicals don't break up over a, right? A minus b square root does not equal to the square root of a minus the square root of b. That's a real common mistake. As a matter of fact, even the sum, right? So let me start trying to plant that seed now, because it's going to come up a lot in our work. So if we're taking the square root of a sum or a difference, it doesn't break up into the square roots of each piece. All right, we just either leave it alone or figure out another way to simplify it. Okay, letter F is actually pretty tough. There's a lot going on here, but once we kind of see the pattern, it's not too bad. Again, we're trying to get sine all by itself on one side, and then some expression that has tangent on the other. All right, and unfortunately, there's not a really crisp, clear sine and tangent. The only one that we have is we know that tangent of x is sine x over cosine of x. And if we multiplied both sides by cosine, what I have is that my sine of x is equal to cosine of x times tangent of x. So the good news is I've got sine by itself. The bad news is I only want it to represent in terms of tangent, and I've got a cosine there. So we need to figure out a way now, how do I rewrite cotangent in terms of that tangent? Okay, and the thing you actually want to do, it seems like we're going to be way out in left field, is let's start with the Pythagorean identity. Tangent squared plus 1 is equal to secant squared. And the reason I'm saying we're going to go here is because what do we know about cosecant? Cosecant, well, this would be 1 over cosine squared x. And so now, right, I have an equation that relates cosine to tangent, which is going to help me over here later on. Let me write this over 1. If we do a quick cross multiplication and solving, we essentially get that the cosine squared of x is 1 over the tangent squared of x plus 1. And so if we take a square root, again, that's going to give us a plus and minus. We find that the cosine of x is plus or minus. Well, the square root of 1 is 1. And then we get the square root of tangent squared x plus 1 over here. Okay, and again, so now I have my cosine in terms of my tangent. And then again, don't fight the urge to break this radical up over that sum. As I mentioned, it doesn't break up. So we're ready, right? Now that I have cosine in terms of tangent, I'm going to come replace that. So we find that putting this together here, if I replace this cosine with what I have here, I got plus or minus 1 all over the square root of tangent squared x plus 1 times the tangent of x. And let me clean that up. So the sine of x in terms of tangent is plus or minus the tangent of x all divided by the square root of the tangent of square x plus 1. And so now I have my sine by itself, and on the other side we just have an expression of tangents and cotangents. So that is the trick right there. Since there wasn't an immediate, nice, clear relationship, like up here there was a nice immediate relationship between cosecant and cotangent, I just used it. Here, right, there was a link between sine, cosine, and tangent. I had to get rid of the cosine. So I ended up using the Pythagorean identity that relates secant to tangent. But once we have secant, we have cosine, and then I was able to solve for cosine and go for that. So lots and lots of algebra. Hopefully you guys can begin to understand why I was making you guys work with fractions and making you guys show your algebra work, because we definitely need it in Chapter 5. So hopefully there's going to be a payoff, even though a lot of you thought I was torturing you in the past. A lot of algebra work coming up. All right, so that wraps up rewrites and simplifications. We'll do a little bit more in another video coming soon, since this one has gotten quite lengthy.